All right, let's begin on our Mission 4, End of Mission Study Guide, finishing out Mission 4. Okay, and you can see on this study guide, I have added something different. This is going to tell you how many points each of the questions are worth. Okay, so as you can see, the first two questions here are each worth 10 points. The third question is worth 14 points. If you look on the back, question number 4 is worth 22 points, and that's the first part of question number 4, because the second part, part B of question number 4, is worth 24 points. So we have two parts to this question. We have a part A, and then we have a part B. Part A is worth the 22 points, part B is worth the 24 points, and then we have our last question here worth 20 points. All of that adds up to a total of 100 points. Okay, so you can see on here how much each of the questions are worth. Okay, let's go ahead and get started with question number 1. Find 4 divided by 2/5. Use the tape diagram to support your answer. You have to use this tape diagram in order to earn your 10 points. You cannot just put the answer here after the equation and get the points. You must show your work on the tape diagram. Okay, so we're going to find how many 2/5. We're going to find how many 2/5 are in 4. Okay, you practice this lots of times on your Zern. So hopefully you've completed those Zern lessons, because your Zern has you practice this over and over again. All right, so we have to see how many 2/4 are in 4. Well, in order to do that, the first thing we have to do is have 4. So we're going to go ahead and take this tape diagram, and we're going to have it represent 4 holes, right? 4, the number 4. So this whole tape diagram represents 4. Now we have to see how many 2/5 are in 4. Well, in order to make groups of 2/5, we have to have fifths, right? Our denominator there tells us that these are going to be groups of fifths, 2 in each group, right? According to our numerator, 2/5 in each group. So I'm going to go ahead and show those fifths in each one of my holes, because if this is 1 and I break it up into 5 pieces, each of those pieces will be 1/5, and then I can make groups of 2/5. So I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 5 parts in the first hole. 1, 2, 3, 4, 5, right? We've got 1, 2, 3, 4, 5 in that hole. 1, 2, 3, 4, and 5 in that hole. And 1, 2, 3, 4, and 5 in that hole. Okay? So, and I'm going to grab a different color just so that you can see where the holes are separated. Okay, so I've got a group of 5/5 here, a group of 5/5 here, a group of 5/5 here, and a group of 5/5 here. That's what makes a total of 4. Now what I'm going to do is I'm going to group those into groups of 2/5. Well, here's 1, 2. This is 2/5, right? You can see here, here's 1/5, 2/5. So I'm just going to keep that pattern going. This is the exact same thing that you did on your Zern. So here's another 1, 2/5. And then here's another 2/5. Does it matter that it's going from one whole to another? Nope. Here's another 2/5. Here's another 2/5. And another 2/5. Two-fifths. 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 And lastly, 2/5. So now I figure out how many 2/5 do I have? Well, I made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 2/5 in 4. So my answer is 10. I made 10 2/5 in out of 4. All right, number 2. So we showed using a tape diagram. Now we are going to use our algorithm. Okay, it says to show your reasoning. That's the same as saying show your work. Okay, showing my reasoning is the same as saying show my work. So I need to see the steps of how we divide 14/25 by 7/5. So we want to see how many 7/5 are in 14/25. But instead of drawing our tape diagram to solve this, we're going to show our work using our algorithm. The steps for our algorithm are on the board, right? If we don't have those memorized yet, the steps of the algorithm are written on the board. But step 1 says that both the dividend and the divisor must be in fraction form. Well, I can see right here, 14/25, that's a fraction. 7/5, that's a fraction. So step 1 is already done for me. Step 2 says to keep my dividend. All right, so I'm going to keep my dividend just the way it is, right? Step 3 says to use the inverse operation. Well, the inverse of division is multiplication. And then it says to use the reciprocal of the divisor. Well, the reciprocal of 7/5 is 5/7. All right, I've rewritten my equation here. Next thing I have to do is simplify. So I'm going to go ahead and I'm going to see, can I simplify? I always look to the diagonal values. 14 and 7. Is there a value that can go into both 7 and into 14 equally? Yeah. 7 can go into 7 once, and 7 can go into 14 twice. Okay, so I've simplified both 7 and 14. Is there a value that can go into both 5 and 25? Yeah. 5 can go into 5 once, and 5 can go into 25 5 times. Okay, so those are my simplified values now. So I'm just going to rewrite my problem now using my simplified values. That means that I have 2/5 times 1/1, and then I just multiply straight across. That means 2 times 1, which is 2, and 5 times 1, which is 5, and that makes 2/5 my answer. That means that there are 2/5 of a group of 7/5 in 14/25. All right. Used my tape diagram, used my standard algorithm. Now we're going to apply this knowledge to finding the missing width of a shape. All right, now the first thing that we have to know, because this says the area of the rectangle is 24 square units. I can see that right there. The area is 24 square units. That means that if I broke this up into squares, there would be 24 of them that cover this space, okay? And it says, what is the width of the rectangle? Write and solve a division sentence to find the width of the rectangle. A division sentence is the same as an equation. Well, they've given me my length. I don't know my width. I do know my area. I can solve this. I have to know the formula for area is length times width equals area. Okay? Length times width equals area. Now I'm going to change the letters that represent the parts of the equation with the actual values that I know. I know the length, so 5 3/5 times the width, I don't know the width, equals the area. I do know the area, 24. So I have 5 3/5 times, don't know, equals 24. Well, can't solve it like that, can I? But I can create my related division problem, which is going to be 24 divided by 5 3/5, and what I'm going to figure out is what that equals. All right, I have a division equation. I can solve this using my standard algorithm. So 24 divided by 5 3/5, don't know what it equals. Step 1 of my algorithm, have to have a fraction for both the dividend and the divisor. I don't, so I'm going to go ahead and change these into fraction form. 24 is going to become 24 over 1. 5 3/5, well, I know that in order to change this from a mixed number, I multiply the whole number times the denominator plus the numerator over the denominator. So 5 times 5 is 25. 25 plus 3 is 28, and that's over the denominator of 5. So that means that I have 28 over 5. All right, so 28 over 5. Now I go on to the next step. Keep my dividend, inverse operation, reciprocal, and I take a look. Can I simplify? Well, 5 and 1. There is nothing that can reduce 1. 1 is already, or simplify. There's nothing that can simplify 1. It's already simplified all the way, so I can't simplify those two. But 24 and 28, is there something that goes equally into both 24 and 28? Yes, 4 goes into both 24 and 28 because 4 times 6 equals 24 and 4 times 7 equals 28. So that means that 4 goes into 24 6 times and 4 goes into 28 7 times. Okay, so now I'm just going to go ahead and I'm just going to do that to show that I am going over here to make more room. So that means I have 6 over 1 times 5 over 7. And I can multiply straight across, right? 6 times 5 is 30. 1 times 7 is 7. So I have 30 over 7. Now, I will accept 30 over 7, but that is an improper fraction. And so what I really should do is figure out what the mixed number is for that. So So 30 over 7. What that means is how many groups of 7 are in 30, because groups of 1/7, 7 groups of 1/7 makes a whole. So I want to see how many groups of 7 are in 30. So let's see, let's go ahead and use my my knowledge of my 7s. 7, 14, 21, 28. Oh, that's as far as I'm going to be able to go without going over 30. So that means that I made 4 groups of 7. That means there's 4 wholes. And I didn't use all of them, right? The difference between 28 and 30 is 2. So that means there's 2 7ths left. So that means that the missing length here is 4 and 2 7ths. That means the rectangle is 4 and 2 7ths units wide. All right, let's go ahead and look at the back side. All right, these questions are worth a lot more points. Why? Because they're a lot more challenging. Okay, we're going to have to do a lot more deeper thinking. Excuse me. So number 4 is broken up into part A and part B. So both of these are using the information from number 4 here. All right, number 4. Mr. Wheeling is packing a moving box that has a total volume, that means that how much space is in the box, of 514.5 cubic inches. The box is 7 inches wide and 21 inches long. All right, so, and I can see that here on the model. It's 21 inches from this side to this side, right? From that corner to that corner. It's 7 inches from that corner to that corner. Inside the box, if I was to measure it in cubic inches, would be 514.5 cubic inches. Part A says, for 22 points, what is the height? That means how tall, right? That's what I don't know. How tall is, or what is the height of the shipping box? It says moving box here, but shipping box. Show your work. All right. Just like I had to know the formula for area, I need to know the formula for volume. And volume is length times width times height equals volume. Now I'm going to go ahead and replace the information that I know for that formula. So my length is 21. My width is 7. I don't know my height. My volume is 514.5. Okay, so there's a little bit of math here that I can do so that I can simplify this equation. I can multiply 21 times 7. 21 times 7. Well, 7 times 20 is what? 140. 7 times 1 is 7. So that's going to be 100 and, what did I just say? 147. Times, don't know what, equals 514.5. Okay? Now, I have a multiplication equation that's missing a factor. That means that this can get changed into a division equation. So I'm going to go ahead and flip that into its related division equation. 514.5 divided by 147 equals, I don't know what. That's what I need to solve, okay? And I have a division equation that includes a fraction. That means that I can use my standard algorithm to solve it. Step 1, I have to have both a fraction for the dividend and the divisor. Well, how do I change a mixed number into a fraction? I multiply the whole number times the denominator, and I add the numerator. So that's going to be 514 times 2. Well, 2 times 500 is 1,000, and 2 times 14 is 28. So that's going to be 1,028, but I've got to add that 1, so that's going to be 1,029. 1,029 over 2. Keep my denominator. And I'm going to divide that by 147, so I'm going to change that to 147 over 1. All right, go on to step 2, and I'm going to go ahead and go over here. So I've got to go to keep my dividend, 1,029 over 2. I've got to change my my operation to the inverse, so division is going to change to multiplication, and I've got to do the reciprocal of my dividend, of my divisor, so that's 1 over 147. Okay. Now, next step says to simplify, so I cannot simplify 2 and 1 because 1 is as simple as it gets. 1 cannot be simplified. Now, these are some big numbers here, aren't they? Well, guess what? I'm just going to go ahead and see. Does 147 go equally into 1,029? Can I divide 147 by both 147 and 1,029? It's worth a shot, right? So I'm going to grab my handy-dandy calculator. And I'm going to go ahead and I'm going to put in there, I don't know if you can see that on the screen, but I'm going to go ahead and put in 1,029 divided by 147, and look at that, it goes in 7 times. So that means that 147 can be divided by 147, and it goes in once, and 1,029 can be divided by 147, and it goes in 7 times. Okay, so now I'm going to go ahead and rewrite my equation simplified. That means 7 halves is being multiplied by 1 over 1. Well, what happens when we multiply 7 times 1? We get 7. What happens when we multiply 2 times 1? We get 2. That's an improper fraction, so I'm going to go ahead and take my 7 over 2, and 7 goes into 2, 2, 4, 6, 3 times. That means I can make 3 wholes, and the difference between 6 and 7 is 1, so that means I have 1 half left. So that means that the height of my box, right, because I didn't know, is 3 1/2. And my answer is 3 1/2 inches. That is my height. Height is 3 1/2 inches. Okay, now let's go on to part B. Now remember, this is still having to do with this information that was given to me for number 4, because this is 4B. So Mr. Wheeling is packing the shipping box, so this box that has a total volume of 514.5 cubic inches, that has a length of 21, a width of 7, and a height of 3 1/2. He's packing that shipping box with Rubik's Cubes. You guys know what those are, right? They're those fun toys you flip, turn, try to get the same color on all sides. He's packing it with Rubik's Cubes. Cubes, right? What do we know about cubes? Cubes have the same dimension all the way around. No matter what edge you measure on a cube, all going to be exactly the same. And they have an edge length of 7 halves. 7 halves? That sounds familiar. 7 halves. 7 halves is equal to 3 1/2. Okay, so if one edge is 7 halves, that means all edges are 7 halves. It's 7 halves tall, it's 7 halves long, it's 7 halves wide, because it's a cube. Cubes are like 6 squares. So it's the same dimension on all sides. If he completely fills the shipping box, how many Rubik's Cubes can he ship? show your work and or explain your reasoning. So that means if he puts cube, 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 you know, if he lines them up, fills up this box up here with Rubik's Cubes that are 7 halves on all sides, because if it's on one side, it's on all sides, because it's a cube, how many can he fit? All right, well, what we're going to have to do is figure out how many Rubik's Cubes I can go along this side, how many Rubik's Cubes I can go along this side, and how many Rubik's Cubes I can stack tall. That means I'm going to need to see how many Rubik's Cubes fit in the length, how many Rubik's Cubes fit in the width, and how many Rubik's Cubes fit in the height. Well, I already know the value of all these dimensions. The length is 21, the width is 7, and the height is 3.5, which is the same as 7 halves. And I have to see how many times 7 halves fits into that. I have to see how many times 7 halves fits into that. Then I can multiply the length times the width times the length times the width times the height to see how many Rubik's Cubes fit in there. Well, let's see. We have to take 21 and divide it by 7 halves. Now, we remember from our lesson that if we take a whole number and divide it by a unit fraction, all we have to do is multiply that whole number times the denominator. But if we are dividing a whole number by a fraction that is not a unit fraction, we have to multiply the whole number times the denominator divided by the numerator. Okay? So that means that this, in order to solve this, we're going to take 21, multiply it by the denominator. That's our first step. Remember this? Divided by our numerator. For the width, we're going to multiply 7 times the denominator and divide by the numerator. And over here, let's see if we even need to do this step. 7 halves divided by 7 halves. Well, any number divided by itself, that equals 1. I already know the answer to that. Any number divided by itself equals 1. So I'm going to have to go ahead and solve these guys over here, okay? I know I could work this out independently, right? I can say 21 times 2, that's 42. If I know my multiplication facts, I know that 7 goes into 42 6 times, because 6 times 7 is 42. If you do not feel confident with your facts, you can use your calculator to do this part of your computation. When you are doing this, you need to make sure that you are doing this step and pressing enter before going on to the next step. So you would need to take 21 and multiply it by 2, then press enter. My calculator turned off. Press enter and then go ahead and click that division symbol and divide by 7, and you'll see that you get 6. Okay, 7 times 2 is 14. 14 divided by 7. Well, I know that 7 times 2 is 14, so that means it goes in 2 times. And then I've got 1 down here. So now if I do length times width times height of these values that I just found, right, that's going to be 6 times 2 times 1. Well, 6 times 2 is 12. 12 times 1 is 12. That means my answer is 12, and that means that Mr. Wheeling can fit 12 Rubik's Cubes in the box. All right, last one. Number 5. Mrs. Stapleton is making snack bags for her class. If she can fill 3/5 of her snack bags, so 3/5 of her snack bags. That must mean she has 5 snack bags, and she can fill 3 of them. 3/5 of her snack bags. 3 out of 5 snack bags. Okay? If she can fill 3/5 of her snack bags with 3 1/3 cups of pretzels. Okay, so 3 whole cups of pretzels and then another third of a cup. Gotcha. So she can fill the bags with 3 1/3 cups of pretzels. How many cups of pretzels are needed to fill all the snack bags? Write a multiplication equation and a division equation for the situation. Then answer the question. Show your reasoning. So show your work, right? Okay. I'm just going to kind of draw a quick picture just so that I know that I understand what's really going on here. So out of 5 bags, she can fill 3 of them. I'm going to draw a tape diagram that shows this. So I've got 1, 2, 3, 4, 5 bags. These 5 parts represent my 5 snack bags. And I know that 3 of these bags, right, 3/5, 1, 2, 3 of the bags are filled with 3 1/3 cups of pretzels. Okay, so this is the 5 bags. The whole thing is the 5 bags. 3 of the bags uses 3 1/3 cups of pretzels. The question is, how many cups of pretzels are needed to fill all the snack bags? I have to write a multiplication and a division equation. All right, well, I'm going to have to multiply that 3/5 times something in order to get 3 1/3. Well, so I'm going to multiply 3/5 times I don't know what equals 3 1/3, which means that 3 1/3 divided by 3/5 is going to give us the answer that we're looking for, right? So that's going to give us our answer that tells us how many cups of pretzels are needed to fill all the snack bags, all 5 snack bags. All right, so I'm going to go ahead and use my standard algorithm to solve this problem. Well, first step says that I have to have a fraction for both my numerator and my denominator. So that means I have to multiply my whole number times my denominator plus my numerator. 3 times 3 is 9, plus 1 is 10. So that means that I have 10/3 divided by 3/5. I don't have to change that. It's already in fraction form. Okay. Next step tells me that I have to keep my dividend. So I'm keeping my 10/3. Change my symbol from division to multiplication because I'm doing the inverse operation. And change 3/5 to 5/3 because I'm doing the reciprocal. Alrighty. So now I have 10/3 times 5/3. And I'm gonna, let's see if I can simplify any of this. 10 and 3. There's nothing that goes equally into these, right? 3 can go into 3, but 3 can't go into 10. And then 3 and 5. 3 can go into 3, but 3 can't go into 5. So I can't simplify this. You can't always simplify your fractions for multiplication, and that's okay. It's just a step that is handy if you can. So I'm going to go ahead and I'm going to multiply across. 10 times 5 is 50. 3 times 3 is 9. Okay, well, that 50/9, that's weird. I don't measure like that, right? So I'm going to go ahead and see what mixed number this actually equals. How many times does 9 go into 50? Well, let's go ahead and use our knowledge of our facts. It goes 9, 18, 27, 35. I can keep going, right? 35. That, I don't know why I said 35. It's not 35. 36. That's why my brain went, where? That's not right. 9 more than 36 is 45. Can I keep going with another 9? Nope. So I'm going to stop and see how many groups I made. 1, 2, 3, 4, So I'm able to make 5 groups. That's 5 cups. And the difference between 45 and 50 is 5. That means that I have 5/9 left. So that means that it is going to take 5 and 5/9 cups to fill the bags. So now I'm going to answer that in a full sentence. Miss Stapleton needs 5 and 5, oops, almost turn that into a G, 9 cups of pretzels to fill all the snack bags. Okay, that will be your test that you will take tomorrow to finish out Mission 4. Hopefully you listened to this video. You didn't just fast forward through it in order to just write down what I wrote. And I hope that you practice and that you study and that you have completed all of your Zern lessons, because that gives you more practice. And after Thanksgiving holiday, we will start on Mission 5.